Okay, so here's part 2 of our video. Okay, so I'm going to be moving a little bit quicker through these. If you guys hopefully can follow along, right? So I'm going to share my screen. See this. All right. So looking at the next question, if you ever need to pause the video, please do so. We'll be good to go. Okay, so number 3, if we read it, ball A of mass A. Okay, so let's see. After the collision, still the same. What is the mass of ball B? Okay. Ball A of mass 5 kilograms moving into one collides with ball B of unknown mass in the same direction. Okay. So let's see. You're gonna have 5 times its 20, plus we don't know the mass times 10. So what that's going to be equal to, after the collision, ball A moves 10 meters per second. So ball A moves 10 meters per second. Ball B moves 15 meters per second. Okay, so when you rearrange this equation, you have 100 plus 10 m's is equal to 50 plus 15 m's. Okay, so 50 is equal to 5 m's. So m is equal to 10. Okay. Now, part B says, was this inelastic or inelastic collision? All right, so what we have to do is solve for our kinetic energies of both of these. All right, so we look at my kinetic energy initial. Okay, so initially, all right, so I have 1/2 mass of the first ball, 5 times its velocity squared. So let's say 20 squared, plus the other ball's initial energy, so 1/2, 10 times 10 squared. Okay, and to do the same thing, kinetic energy final, 1/2, 5 times 10 squared, plus 1/2, 10, 15 squared. Okay, so my kinetic energy initial is actually 1500 joules. My kinetic energy final, I got to be around 1375 joules, which means these kinetic energies are not the same. So that means inelastic collision. That means inelastic collision is your answer. Okay. Let's keep moving on. 4. Tim is driving a car that has a mass of 420 kilograms with a velocity of 22 meters per second east. Okay. As he is driving, he hits a deer traveling north. All right, so we're going to have to consider our multiple factors here. Okay, so momentum, we're going to say in the x direction. All right, so he's traveling in the x direction, so he has a 420 car traveling at 22 meters per second. He hits a deer, but the deer is not traveling in the x direction. So, okay, so what that is going to equal is 9,240. Okay, so look at him in the y. Okay, so he's not traveling in y. However, the deer is traveling 100, or has a mass of 120 times v. Okay, so if my momentum, all right, so let's check this out. The question says, if after they crash they moved at an angle of 22 degrees. Okay, so at an angle of 22 degrees, I'm going to draw a triangle, 22 degree angle. Okay, in my x direction is 9,240. how fast was the deer going? So what I got to do is I got to find the momentum in the y. So I'm going to find the momentum in the y direction. Okay. So to do that, I'm just going to do the tangent. 22 is equal to opposite over 9,240. So the opposite in the y direction should be 3,733. So what you can do is you can set 3,733 is equal to 120 v. So the velocity of the deer was 2 sig figs, 31 meters per second. Okay, the velocity of the deer was 31 meters per second. Now, it says, what is their final velocity with the direction after the collision? Okay. So, after the collision, well, we know, let's see. We'll have to solve for momentum final. Okay, so if you do a squared plus b squared equals c squared, the final velocity is 9,965, somewhere around there. Okay, and what that is going to, okay, so actually that's my momentum. That's my momentum final. Oh my word, I'm so sorry. Momentum final. So my momentum final is actually equal to the mass of object 1, mass of object 2 times their velocity final. Okay, so 9965 is equal to the combined masses is 540, VF, so VF is 18 point, well, 2 sig figs, 18 meters per second. At the angle was 22 degrees. That was given in the problem. Okay, so that's how you would solve for the velocity final. After the collision, you would have to combine their masses. Okay, number 5. Okay, a 860 kilogram Escalade traveling. So similar type problem, just a little more challenging. Okay, because you got to kind of draw it out. Okay, so what we got here is an Escalade. So the Escalade has a 72-degree angle. Okay, so it says it is traveling 40 meters per second. Okay, so 40 meters per second. So this is the Escalade. And 210, well, that'd be 90, 180. So 210 would actually be a 30-degree angle down here. Okay. And they were traveling at a speed of 22 meters per second. And that was the Mini Cooper. Okay. That's the Mini Cooper. So what this actually kind of looks like is once you set that up, you will be able to find the X and Y's. Okay. So let's do the bottom. I mean, you're just going to be using sine and cosine. So SOHCAHTOA. Okay. So for the bottom, we got about 12.36, about 38.04. For the flat, I got 19.05 and 11. Okay. And that's actually going in that direction. Okay. Right? Because it was negative. Okay. So if we look, we've got to find my momentum in the X, momentum in the Y. Okay. So momentum in the X, what you've got is mass. So let's do the Escalade mass. The Escalade 860 times its X direction, 12.36, plus the momentum of the Cooper, which is actually going, well, let's do its mass. Mass is 220, but it's actually going left, so it's going to be negative 19.05. Okay, and I got that to be about 6,439. All right, similarly, let's do the y direction, 160 times 38.04, okay, plus the mass of the Mini Cooper. And since it's going down, it's negative 11, okay? So that's equal to 30,204, okay? So we have our total, x, okay? So we have our total x is 6,439. We have our total y, it's 30,294. So you got to find for the hypotenuse, a squared plus b squared equals c squared. So the hypotenuse actually is, it got to be about 30,971. Okay, so that is the momentum final. So it says find what velocity the two cars are after the collision. So you got to find mass of object 1, mass of object 2, final velocity. Okay, so when you combine their masses, I combine them, so that's 980. What you're going to do is divide 980 on both sides, and the final velocity is 29 meters per second. Now, don't forget to add an angle. So solve for the angle right here using inverse tangent. The angle I got to be was 78 degrees. Okay. Okay. Let's see. Find the total impulse on the graph. Now, I would love to do this problem for you guys, but you just got to solve for area. Okay, solve for the area, solve for the area, and solve for the area. Okay, so triangle is 1/2 base times height, square or rectangle, I guess it is, base times height. So the area for the first triangle, I got to be 3. For the rectangle, I got 12. For the other triangle, I got 6. And for this triangle, I got -2. Okay, I got -2. So if you combine all of those numbers, 18, 21, I got 19. The impulse is 19 kilograms meters per second. Okay. Number 7. Number 7 says a grenade is tossed on the ground with a velocity of 6 meters per second west. If the grenade explodes in 2 pieces, one has a mass that travels that. What is the mass of the second piece? Okay. So, wow, that's pretty easy. So, the first part, if the total is 0.86, the first piece had that. So, the mass of the second piece is 0.54 kilograms. B is a little more tricky. Okay, so remember, initially, my momentum initial is equal to my momentum final. Initially, it's all one piece, right? So the entire grenade, 0.86 kilograms, is thrown 6 west. Ooh, that's going to be -6. Okay. So that is going to be equal to the mass of the first piece, 0.32 times 10, plus mass of the second piece times its final velocity. Okay. And when you solve for final velocity, Vf ends up equaling -15 meters per second. Okay. Number 8. Number 8 says, let's see, a car, 1,800 kilogram, going 41 meters per second, rear ends a truck, 55, going that. What are their velocities after an elastic collision in the one dimension? Okay. Man. Okay, so I would love to do this problem for you. I'm going to describe how to do it, but I don't feel like doing the entirety of the problem out. Okay, so what you got to do is you got to solve for one of the factors. So let's say you solve for the velocity of the car. Okay, so you're going to set the entire equation equal to vt. Or, well, you could do either actually. Okay, but it's going to be a substitution problem. Okay, and you're going to have to substitute the values from one into the other. Um, so yeah, we're gonna skip that problem. You will not see that problem on your test. Honestly, I asked the other teacher about it, and he said you probably won't even see that on the AP exam. So we're actually gonna skip number 8 and go to number 9. So let's check out number 9. So number 9 says a zero point 0.1 kilogram hockey puck traveling 7 meters per second at 42 degrees collides. Okay, so once again, it's another problem where we have a 42-degree angle. It's traveling at 7 meters per second. Okay, got to find your x, got to find your y. Okay, let's see. Collides with another hockey puck traveling 5. So it's traveling 120 degrees. So it's actually traveling that way. This is going to be 60 right here. Okay, so here you're going to have to solve for your x and y. Okay, so when you solve for your x and y's, I got 5.2, 4.7, I got 4.3, and 2.5. Okay, so that's when you solve for your x and y's. That was given. Okay. All right, so let's see what we got. So the question says, afterwards, what is the speed and direction of the second puck after the collision? Okay, so, well. All right, so let's do this one at a time, okay? So make sure you can see. My initial, the x is equal to my velocity x. Okay, so let's do the x first. 0.1 times 5.2 plus 0.1 times negative 2.5. So that has to equal 0.1 times negative 3. Hold on. What I do? Yeah, no, we're good. We're good. Okay. Minus. That's going to be 2 point. Oh, the final. Final. Okay, so 0.1. After it was traveling, afterwards, the first puck moved 6 meters per second angle. So afterwards, okay, I know where I messed up. So this was all initial. So afterwards, the first puck traveled 6 meters per second at 130 degrees. So it traveled 50. So afterwards, 0.1, and my x, okay, my x is going to be negative 3.9. So that's my x plus 0.1 of the velocity, second one in the x, okay? Then you're going to do the same thing for the y, okay? So for the y, you're going to have, I'm going to write kind of small. I'm going to zoom in a little bit so you can see it. 0.1. Initially in the y, so 4.7, 4.3 equal to 4.6. That's what I saw for right there. 4.6. Velocity 2 in the y. Okay, so when you find your velocity in the x, x should have been 6.6, y should have been around 4.4. So when you do it, x 6.6, y 4.4. When you solve for your hypotenuse, you should get around 7.9 meters per second, and the angle should be around 34 degrees. Okay, that was kind of a longer problem. All right, we're almost done. All right, challenge questions. Okay. So indeed, these are quite extensive. Okay. So let's check them out. Okay. Okay. So a 5 kilogram bullet is fired horizontally into a 1.2 kilogram wooden block resting horizontally on a surface. The coefficient of kinetic friction between the block and the surface is 0.2. Okay. Let's see. All right. The bullet remains embedded in the block, which is observed to slide 0.31 meters along the surface before stopping. What was the initial speed of the bullet? Okay. This is a long one. So mechanical energy initial is equal to mechanical energy final. So if you look, there's no potential energy in initial. Okay. There's no potential energy at all since it's on a surface. Height is 0. Okay, so I am going to have kinetic energy on the initial, and I'm also going to have work non-conserved. Okay. Now, is there any elastic potential? No. Is there any kinetic energy? No. Is there any potential energy? No. So it's all going to be equal to 0. Okay. So we have kinetic energy is 1/2 the mass. Okay, so the mass of the block plus the bullet. So remember, this is tricky. Convert that to kilograms, 0.005. Okay, times that by velocity squared. Plus work non-conserved. Okay, so what we have here is the force of friction times 0.3 times it by. Okay, so remember your work non-conserved. So now you have the x and the angle. Okay, so if we look at this, you're going to have to find the force of friction. Okay, so force of friction is equal to the mass. Okay, so you have the mass times gravity. The force of gravity, so mass would be, let's just do 1.205 times 9.8 times friction coefficient. So that's force normal. Friction coefficient was 0.2. Okay, so you can plug all of this into force of friction, and remember all of that should equal 0. Okay, so when you get this answer, the velocity is 1.1 meters per second. Okay, so that is my velocity final of the object. Okay, velocity final. So to solve for the initial speed of the bullet, you're going to have your potential energy initial is equal to potential energy final. So initially, you have the mass of the bullet, 0.005 times its velocity. Sorry, that's supposed to be a v. Okay. Plus mass of the block times its initial velocity, which I love, times the velocity, or masses combined, 205, times its velocity, which we just solved to be 1.1. So the initial velocity of the block, or of the bullet, with 1 sig fig, I got 300 meters per second. That's more like it, better than the other bullet question. Okay. Number 2, long question. Okay, number 2 says, in a shipping company distribution center, an open cart of mass 50 rolling to the left at a speed of 5 meters per second. So here, you're going to have to look at all of our values. What is the speed of the package just before it lands on the cart? Okay. So we got to look at what we know. Okay. What we know is there's a 37-degree angle. Okay. We know that the box was traveling and it leaves the chute at 3 meters per second. So it leaves the chute at 3 meters per second. Okay. We know that. Okay. So we can solve for our x and y, so up top. So let's do that. So my y is going to be 1.81 going down. My x is 2.4 meters per second in the x and y. Okay. And we know the height is 4. Okay. So in the x direction, okay, in acceleration in the x direction, 0. Okay. My Vx is 2.4. The y, we know acceleration is 9.8, negative 9.8. Okay. We know its initial velocity. Its initial velocity was negative 1.81. We know its delta y was negative 4. Okay. So from that information, we can actually solve for velocity final using our velocity final squared to go to velocity initial squared plus 2a delta y. Okay, we can use that equation. Okay, so if you plug in all the numbers, initial velocity, acceleration, y, our velocity final, I got to be about 2.4 in the x direction. Okay. Or, hold on. No, I didn't. Velocity, that's my bad. I'm getting confused. We've done this for a minute. So velocity final in the y direction, I got negative 9, negative 9 meters per second. Okay, so that's velocity final in the y. Okay, so let's see what would the speed of it's just before it hit the box. So my velocity final in the y, 9.13. I knew my velocity in x, my final velocity in the x, was 2.4. You can solve for the hypotenuse, and when you solve for the hypotenuse, you got a velocity of 9.44 meters per second. Okay. That's how you would solve for the first one. Okay. All right. Now, part B says the speed of the package just before it lands in the car. Oh, that's what we did. The final velocity of the car. Okay, what's important to know for this problem is since the car is on the ground, the velocity of the package in the y direction does not affect the momentum of the car's motion. So we will only look at the momentum in the x direction. Okay, so momentum in the x, remember, so since they're separated, my initial, so I'm going to have mass of object 1 times its initial velocity in the x plus
Caitlin Leonard, can you come to the receptionist desk? Caitlin Leonard.
X is equal to the combined masses, 65, times velocity final. The velocity final in the x direction, in this case, is negative 3 meters per second. All right, last problem. Last problem. Let's rock and roll. A 3.4 kilogram firework rocket is launched vertically into the night sky with an initial speed of 44.2 meters per second. The rocket explodes and breaks into 2 pieces 3.1 seconds later. What is the mass of the second piece? Okay. Then part B says, what is the velocity of the second piece after explosion? Okay. So if my firework, let's do A. A is easy. If the firework weighs 3.4 and one of the pieces weighed 2.1, the mass of the other piece had to be 1.3 kilograms. Now B is a little more tricky. B is what is the velocity of the second piece? All right, so what we can do, there's a lot of different variables we have to work with here. Okay, so if it's fireworks being shot up, I drew a little picture. Okay, fireworks being shot up at 3.4, a 3.4 kilogram being shot up at 44.2 meters per second, 3 point time, then it explodes, and we have the explosion. All right, 22 meters per second. That was given the problem at the angle. So based on that angle of being shot up, okay, so let's say here's my firecracker. Shot up like that. Okay, 40 degree, 22 meters per second. You are able to calculate the x and the y, 16.85. The y is 14.14. Okay. So let's see, find the velocity right before it explodes. So my velocity final, the velocity initial plus acceleration time. All right, so my initial velocity of the firework was 44.2 plus acceleration, which is negative 9.8 times 3.1. Velocity final should be something around 13 meters per second. Okay. So we have that. Okay. Now looking at the momentum. Okay, looking at the momentum, we'll have to solve for the velocity in the x and y directions. Okay. What is velocity after the explosion? Okay, so this was my initial, well, velocity final. So this was the firework going up. Our goal is to solve for the final velocity of the second piece after the explosion. Okay, so what we have, let's do the x initial. So combined mass is 3.4. In the x direction, it's not going anywhere. So the one piece, 2.1, is traveling at negative 16.85. The 1.3, we're going to have to solve. That's in the x direction. The y direction, 3.4, is traveling at 13 meters per second. And then when they separate, 2.1 times 14.14, or 14.4, plus 1.3 times that velocity. So x direction should have been 27.22 meters per second. Y direction, I got to be about 11.26. If you do the combined direction, I got 11 going to be 11 meters per second. Oh my gosh, I am so sorry. It is 30 meters per second. And if you find the angle, it's at 22 degrees. 30 meters. Oh man, my screen froze. Okay, sorry about that, guys. So you have your x, you have your y. Okay, so you solve x and y, and that's your hypotenuse. Okay, that is the study guide. Yowzas. Okay, that took a little while to do. Hopefully, it is beneficial to you guys. If you still have any questions, please shoot me an email. If not, I hope you guys have a fantastic evening, and we will see you tomorrow. Okay.